Greetings. My name is George Blumberg, and I'm speaking from Oxford, England. And I'm going to talk about a project that I'm working on with some of my colleagues at Oxford Brookes University. And the title of the project, the title of the talk is Blockchains for Renewable Energy Microgrids. And what I'm really going to speak about is a proof of concept project for the use of blockchain technology in real estate development projects. And the particular application here is in the data management of renewable energy microgrids, which, if successful, will help achieve our carbon reduction targets. And of course, this is a highly commercial setting. And we really want a commercial model that encourages investment and rewards for community energy projects. And laterally, it's going to help improve the reliability and performance of energy supply. So real estate development is a complex process, but we think that this particular project is applicable in two specific phases or areas. One is in the development of the environmental strategy, and the other is in the commercial strategy. So this project focuses on both of these. And in order to clarify and I guess to explain our system, I've devised a model which has three layers. At the top is the user, and this is a collections of organizations or individuals that actually are part of this trading network. The second layer includes the devices. These are renewable energy devices, of which there are many different types. I'll talk a little bit about them later on. And of course, the bottom layer, what underlies the entire project, is the data layer. And that is management of a stream of sequential recordings that are analyzed, reported upon, and additionally, some action is made for reconciliation. So some billing and payments are actually done as part of this concept. So let's talk first about the user layer. And really, this is a community of individuals, organizations, collectives engaged in commercial trading network. And this is commercial trading of energy, of different types of energy. And of course, it has to be flexible and expandable. Communities shrink and grow, they expand, they change, and also the devices themselves change. So the community-led, the other aspect which is crucial is it has to be a community-led. It has to be sort of democratic, sort of from the ground up organization. It seems to be essential for this type of activity to function properly. And therefore, partnership building is crucial. And we think that the actual partnership phase is during the planning aspect, the planning phase of the development, when investors, potential purchasers or customers, people living there would actually want to engage. Now, just to give an example of what a community unit might look like, I've picture here a community consortium, an energy consortium formed by a group of residents who, perhaps orchestrated by the developer, band together to invest in arrays of renewable energy devices that would plug into an existing network, the larger microgrid, and be configured by the developer. In other words, a balanced system could be assembled. And this has to fit in with a business model which requires device information, the cost, the energy pricing, some sort of reconciliation agreements, financial and environmental reporting. Now, the device layer itself is, I've mentioned, infinitely expandable, and just a few devices here. Wind turbines, they produce roughly, the larger ones produce 690 volt three-phase current. AC current. Water turbines, slightly less voltage, two-phase. Biofuels are an interesting case because they produce both AC current and hot water. So these are cogeneration. photovoltaic arrays, DC. There's a great advantage to having locally accessible DC infrastructure, since so many of our devices now run on DC current. And of course, other systems are being brought online as the technology develops. Now, underlying all of this, and the final part of my talk really, is to talk about the data layer. And that is essentially meter readings of individual devices that are done in such a way that analysis can be formed, error checking done, so that debit and credit can be granted to respective owners. So the device requirements are quite simple. The complexity of the data is not. And the reason is because there's such opportunity for falsification of the data by putting in, rather than a device, put in a system that simply provides false information. So it's very easy to defraud a system like this if it doesn't have error checks, systematic error checks, and if the reliability of the records isn't absolutely foolproof. So blockchain is an obvious choice because of its immutability, its distributed nature, and of course it was used for cryptocurrencies, so that would naturally lend itself to the use of tokens. Tokens could be representative of a unit of energy consumed or spent. Particularly useful in blockchains, particularly useful in recording transactions in complex trading environments, which is exactly the picture, the use case that we have here. And they also allow a degree of autonomy in data collection. You can set a device up and be assured that the data is going to be distributed to the blockchain or to nodes in the network in a reliable, consistent, and uniform fashion. And of course, this type of system induces trust amongst trading partners, which might not already have existed previously. So we use a conventional blockchain structure. We include things like a Merkle tree to ensure that the ordering is done in the correct way. And this is of course essential. The timing and ordering of energy transactions are required to ensure that the commercial arrangements are right. And the consistency in ordering is quite dissimilar from that of a cryptocurrency system, in that it's centralized, and we encode the trading rules within. We can encode the trading rules and the verification rules within the blockchain system. Data management, again, automatically, sequentially record data, allow use of tokens, provide some access or ability to code the business logic, the business trading arrangements. Some devices will have different characteristics. Some users will have different characteristics to others. And of course, a consensus and ordering system, which is highly reliable, decentralized, and robust. And of course, we need to include privacy controls and integrity of the data to provide some sort of protection for the identity of participants. Now, the architecture we've come up with is based on Hyperledger fabrics and using smart contracts to manage the description of these data systems. Essential also to this is the use of a relational database. So besides the sequential data recorded on the blockchain, there's some conversion to a relational database, which can be conventional and used for billing and reconciliation. But it can always be compared against the original data recorded on the blockchain for reliability and for integrity. So this concept that we're working on requires some novelty. And I've broken it down really to two things. One is a central organization that manages the data, system analytics, reconciliation, payments, and so an organization of this could be the residence organization. It could be the developer himself. It could be a contractor that provides a service to an energy collective. And then, of course, we need changes to the planning regulations to offer incentive to these community-led microgrids. And they're not going to happen on their own. They need to be organized, and there has to be some government input into it. So we see these two things as being actually absolutely vital. And of course, if done properly, it would really aid, I think, in for the developer, for the real estate developer, to produce a viable commercial argument. So with that, I open my talk to anyone who has a question. Thank you very much.